So let's take a look at quiz 1. Using an op-amp in open loop mode. So open loop means that there's no connection between the output back to any of the inputs. We're going to add feedback, which you will see will make this a lot more useful device. But for the moment, we're going to apply voltages to the input. We're going to see what happens to the output. We're using our model that basically says we subtract the negative input from the positive input, multiply it by a big number. And then, of course, the output is limited either to the positive or no more than the positive supply, no less than the negative supply. We have a design where we've connected the negative input to ground, and we've connected some sort of voltage source generator to the positive input. And we want to know what maximum peak-to-peak input voltage we can apply without saturating or clipping. And that means without the output going above the 15 volts or below the minus 15 volts. We're using a real-world op-amp in this case. It is the LF411. We're going to use that in class quite a bit. Has a typical spec that the value of the open loop gain, that's A, of 200,000. Now, if you actually look at the data sheet, it may or may not tell you what the minimum and maximum are, but the minimum could be 2 to 4 times bigger. The minimum could be, half as much. You can get a pretty wide range. This is not a well-controlled parameter. We want to know what the maximum peak-to-peak input voltage you can apply in this circuit without causing the output to clip. Well, we know the output can be plus 15 to minus 15, 30 volts peak-to-peak. We have a 200,000 gain, and so that says that 30 volts divided by 200,000 gives us 150 microvolts peak to peak. So if we have a signal that's as small as 150 microvolts, we could theoretically use this in open loop. I say theoretically because in reality, that 200,000 isn't a real number. It could be, as I said, 400,000, probably not that high, maybe 250 to 300,000, but it might be as low as 100, even less than 100,000. So our output isn't very well controlled, and it's not very often we have 150 microvolts. And even if we did have a 150 microvolt signal, we'd have to guarantee that there was no DC offset, because if we had a little bit of DC offset, that would also be multiplied by the 200,000. So this is not a very useful circuit. And in fact, you just built this in the first lab, and I think you noticed that it's almost impossible to not have the output either be clipped at plus 15 volts or clipped at minus 15 volts. So let's take a look at how we can take this device and make it useful. And the trick is going to be applying negative feedback.